Let's work on intermolecular forces now. There are three kinds of intermolecular forces. We have the van der Waals, and then we have dipole-dipole, and finally there is the hydrogen bonding. Hydrogen bonding is the strongest one, and van der Waals is the weakest one. Don't forget. Okay, dipole-dipole is in the middle, and this has polar bonds. Okay, and in case of hydrogen bonding, you need to have hydrogen and nitrogen, oxygen, or fluorine. Okay, that's how it goes. And in case of van der Waals, there is no polar bonds, okay, whatsoever. Now remember, ionic compounds will have what is called electrostatic force, and they will always be polar, always. Okay, so let's take some examples, and the best thing to do is to look at boiling points first. Okay, so that's our first task, is compare boiling points and intermolecular forces. Okay, so let's take two compounds and determine which one is going to have a higher boiling point. So let's say you have this and you have this compound. Okay, this is an alcohol, this is an ether. You can't have very many differences. Okay, you have to have same number of carbons, okay, or same functional group. Okay, something has to be the same for it. Okay, you can't compare apples to oranges. So here we have an alcohol and an ether. So which one has a higher boiling point? And it would be alcohol, because we have hydrogen bonding over here. It's always good to write out everything so you know exactly what you're looking at, all right? And know that it's higher because of hydrogen bonding. Okay, so let's look at another molecule. Here we have another alcohol, and here we have two alcohol groups. Okay, so which one is higher now? And in this case, this will be higher because you have two alcohol groups. Okay, therefore double the hydrogen bonding. That's how you would decide for these two compounds. All right, let's look at another one. And let's say we have this, which is an amine, and we have 1, 2, 3, 4, 5, this, okay, which is also an amine. We have the same formula, so you have CH2, 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 so 5 carbons, okay, and so 10, 11. Here we have 1, 2, 3, 4, 1, 2, 3, 4, 5 carbons, okay, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 hydrogens, okay. I think I missed out this one. Okay, so 11 hydrogens for both. So the only thing that is different between the two is the nitrogen, okay, and how it is connected. We have the double bond also, of course, but the alkenes and the alkanes, they're pretty much the same as far as their intermolecular forces are concerned. The key here is looking at nitrogen, because in this case the nitrogen is primary, and in the case of the cyclic, this is a secondary nitrogen. And in case of the secondary amine, you have less hydrogen bonding, and primary amines have more hydrogen bonding. Okay, so because of the hydrogen bonding, the primary amine is going to have a higher boiling point than a secondary amine. That's how it goes. Let's look at another compound. Between these two, now both of them have a double bond, both of them have the same number of carbons, but this one has an oxygen, which means that this leads to a polar bond. And because this is a polar bond, this has higher boiling point. Okay, and this is because of dipole-dipole interaction. Okay, let's look at another one. And now in this case, we'll take a simple compound. Here we have 4 carbons. Here we have 1, 2, 3, 4, 5, 6 carbons. And 6 carbons is more than 4 carbons because more van der Waals. Okay, so therefore a higher molecular weight leads to more van der Waals forces. Also, this is what we call induced dipole, and induced dipole is a property of when you have large molecules with the high electron density. Okay, and so that's more van der Waals forces there. Okay, so then let's look at another one. Last one. Let's compare an alcohol with a ketone. So here, this is a ketone, this is an alcohol. Alcohol wins. And why? Because of hydrogen bonding. Yep. Okay, so that's about boiling points. Number 2 that's important as far as intermolecular forces is solubility. What is soluble in the other? And remember, the rule is like dissolves like. Okay, you've heard of this in Gen Chem 2. So like dissolves like. Alright, so for example, if you have something like this, this is pentane. Okay, so pentane is non-polar. So it means it will dissolve anything that is non-polar. So example, soluble things in this would be ether. Ether is non-polar. And then alkenes. Okay, so these will be soluble in pentane. All right. If you have pentane and you're trying to dissolve 1, 2, 3, 4, 5 pentanol, then this is not soluble. Okay, because here you have H bonding, hydrogen bonding, and here it is non-polar. Okay, so this is not soluble in each other. So the best thing to do is look for similar intermolecular forces. Okay, that's the key thing to look for when you're looking at solubility.